Welcome back. Today, we're going to tackle something that so many students find tricky, especially in board exams: balancing chemical equations. Stick with me, because by the end of this, you'll have a super simple method to nail it every single time. Let's dive in.
You've probably been there, right? You know the reaction. You write all the chemical formulas perfectly, but you forget to balance the equation. And just like that, you lose those easy marks. It's honestly one of the most frustrating things in chemistry.
Sometimes it feels like magic, doesn't it? You have one oxygen atom on the left and poof, suddenly there are 4 on the right. But I promise, it's not magic, it's just a puzzle. And I'm going to show you the exact steps to solve it, making it feel simple every time.
So why do we even have to do this? Is it just some random rule your teacher made up? Nope, it's actually based on one of the most fundamental laws of the entire universe.
You see, when you first write down who's reacting with whom, you have what's called a skeletal equation. Just think of it like a rough draft. It shows you the ingredients, but not the right amounts. And in an exam, a rough draft just won't cut it.
And here's why. It all comes down to this big idea, the law of conservation of mass. All this really means is that in a chemical reaction, atoms don't just appear out of thin air, and they don't just vanish. Whatever you start with, you have to end with. Simple as that. The number of atoms for every element has to be the same on both sides of the arrow, period. Okay, before we jump into the steps, we need to talk about the one single most important rule. Seriously, getting this wrong is the #1 reason students lose marks on this. Listen up, because this is the golden rule. You can only change the big numbers that you put in front of a chemical formula. These are called coefficients. Think of it like saying you have 4 water molecules. But you can never, ever change the small numbers within the formula, the subscripts. If you change H2O to H2O2, you haven't balanced anything. You've changed water into hydrogen peroxide, a completely different chemical. So remember, coefficients are your tools. Subscripts are totally off limits.
All right, let's get our hands dirty. The method your NCERT textbook talks about is called the hit and trial method. But don't let the name fool you. This isn't just random guessing. It's a really logical, step-by-step process.
We're going to use this classic example straight from your textbook. We've got iron reacting with water or steam to form iron oxide and hydrogen gas. You can see right away it's totally unbalanced.
So, the very first step is to just take a quick count. On the left side, we have 1 iron, 2 hydrogens, and 1 oxygen. On the right, 3 iron, 2 hydrogens, and 4 oxygens. Okay, so our iron and oxygen are the problem children here. Let's fix them.
Now here's a great tip to make your life easier. Always start with the most complicated-looking compound in the equation. In our case, that's definitely Fe3O4. It's got the most atoms. Let's start by balancing the oxygen because it has the biggest mismatch. 1 on the left, 4 on the right.
To get 4 oxygens on the left, we simply place a big 4 coefficient in front of H2O. Boom! Now we have 4 oxygen atoms on both sides. Perfect. But, uh-oh. By fixing the oxygen, we've now messed up our hydrogen count on the left. No worries, this is all part of the process. On the left, we now have 4 times 2. That's 8 hydrogen atoms. So to get 8 hydrogens on the right, we just need to put a 4 in front of the H2 over there. Now we've got 8 hydrogens on both sides. See how that works?
Let's take a look. Our equation is looking way better. Oxygen is balanced, hydrogen is balanced, so what's the only element left to fix? Yep, you got it, the iron.
This is the easiest step of all. We've got 3 iron atoms on the right side, in Fe3O4. We only have 1 on the left, so we just put a 3 in front of the Fe on the left side. And I think we might be done.
But hold on, we're never really done until we do one final, super important check. This is the step that makes sure you get all the marks you deserve. Don't skip it. Okay, so here's what we have. I want you to take just 5 seconds, pause if you need to, and do a quick mental count. Is every single element balanced on both sides?
Let's check it together. Left side, 3 iron, 8 hydrogen, 4 oxygen. Right side, 3 iron, 8 hydrogen, 4 oxygen. Yes, it is perfectly balanced. See? That systematic approach gets you to the right answer every time. So, let's quickly go over the 2 biggest mistakes to avoid in your exam. Number 1, never ever change the small numbers, the subscripts. And number 2, always do that final check. It takes literally 5 seconds and can save you from losing easy marks.
Okay, you've seen how it's done. Now, the best way to get really good at this is to actually do it yourself. So I've got 2 problems for you to try.
Here are two pretty common equations you'll see. They're both from your textbook. My challenge to you is to pause right here, write them down, and try to balance them using the exact steps we just went through. Give it a shot.
So let's do a quick power recap. It's really just a simple 4-step plan. 1. List your atoms. 2. Start with the biggest, most complex molecule. 3. Balance each element one by one using those big numbers in front. And 4. Do that final check. That's it. You've got this.
Hey, if this step-by-step method finally made balancing equations click for you, do me a favor and hit that like button. And make sure you subscribe so you don't miss the next explainer where we'll keep breaking down chemistry to make it easy for your exams.
So now that we know how to write a proper balanced equation, we're ready for the fun part, understanding what these equations are actually telling us. In the next explainer, we're going to start exploring the different types of chemical reactions, starting with a really simple one called a combination reaction. I'll see you then.